Hello friends, today we'll be speaking about acid-base disturbances. As we know, the pH of the blood is maintained at a very narrow range between 7.4 plus or minus 0.03. Some books have mentioned it as 7.4 plus or minus 0.04 or 0.05, which means that the normal pH ranges from 7.37 to 7.34. 7.43. Also, you may consider 7.35 to 7.45 as the normal range. Now, changes in pH are affected by PCO2 and bicarbonate, and this is governed by the Henderson-Hasselbalch equation, which is as follows. Now, you don't really need to know the equation, but what you need to understand is that with an increase in bicarbonate, there is an increase in pH, and with an increase in PCO2, there is a decrease in pH, and vice versa. So, what we can say is pH is directly proportional to plasma bicarbonate and inversely proportional to partial pressure of carbon dioxide. Okay. So, on the basis of this, we now have two terms and four conditions. So, a pH of less than 7.37 is called acidosis or acidemia, and a pH of greater than 7.43 is called alkalosis. Now, based on the primary change in PCO2 and pH and bicarbonate, you have the following conditions. So, if the primary change is a decrease in bicarbonate accompanied by a decreased pH, the term is metabolic acidosis. And if you have an increased bicarbonate with an increased pH, it's metabolic alkalosis. Similarly, if you have a decreased PCO2, let's say an increased PCO2, it's called respiratory acidosis. And with a decreased PCO2, you have respiratory alkalosis. So I'll just draw another table showing you what these conditions mean. So let's say the pH is less than 7.37. The plasma bicarbonate is decreased. The condition is called metabolic acidosis. So this is the primary response, a decrease in plasma bicarbonate. The body compensates by decreasing PCO2 by hyperventilation. Now let's say there is an increase in the pH, it's accompanied by an increase in plasma bicarbonate. The condition is called metabolic alkalosis. And the compensatory change is an increase in PCO2. Similarly, you have a decreased pH where the primary response is a decreased Primary response is an increased PCO2. and this is known as respiratory alkalosis. And this is accompanied by a compensatory response, which is an increase in plasma bicarbonate. Similarly, let's say you have this is 4-3. Now, let's say the PCO2 is grab a pH of more than 7.43 and a decreased PCO2. The condition is respiratory acidosis, and the plasma bicarbonate as a compensation decreases. So at this stage, you should know the normal values for bicarbonate and PCO2. So normal pH is 7.37 to 7.43. Normal PCO2 is between 35 to 45. An average is 40. And the normal bicarb is 23 to 27, the average being 25. So, how do you approach a patient with an acid-base disturbance? How do you read arterial blood gases? So actually you only look at two things. One is the pH, the other is the PCO2. The first thing to determine is if the patient has an acid-base disturbance. So if the pH and or the PCO2 is abnormal, you have an acid-base disturbance. So if you have a decreased pH and a decreased PCO2, the primary acid-base disturbance is a metabolic acidosis. And if you have a increased pH and an increased PCO2, the primary acid-base disturbance is a metabolic alkalosis. So what it means is, if the pH and the PCO2 change in the same direction, the pH and the PCO2 change in the same direction, there is a primary metabolic disorder. And if the pH and the PCO2 change in opposite directions, you have a primary respiratory disorder. So if you have a the pH is decreased and the PCO2 increased, it becomes a PCO2 is increased, it's in opposite direction, so respiratory. Because the pH is decreased, acidosis. Similarly, if your pH is increased, because it's increased, it's alkalosis. PCO2 is decreased. Now this is in opposite directions, so there is a primary respiratory alkalosis. Now all of these are accompanied by secondary responses. So again, in the first step, now let's say if you have only either the pH or the PCO2 being abnormal, there is a mixed acid-base disorder, because the compensatory mechanisms only serve to decrease or attenuate the changes in pH. They do not bring the pH back to normal. So in the case of an abnormal PCO2, you have a normal pH, there is a mixed acid-base disorder. So similarly, it's very simple to understand. If the pH is decreased and the PCO2 is normal, now because of the decreased pH, the acid-base disorder is identified now as a mixed metabolic alkalosis, metabolic acidosis plus a respiratory alkalosis. Because if the pH is decreased, the PCO2 should also decrease in a patient with a primary metabolic acidosis. If the pH decreases, because of a decreased plasma bicarbonate, the PCO2 should also decrease. But there is some other factor that is increasing the PCO2 to make it normal. So the patient has a respiratory alkalosis. The same thing can be said with an increased pH. So we'll have a mixed metabolic alkalosis with a respiratory acidosis. Now let's say you have the pH being normal and the PCO2 changes. Okay, now the PCO2 increases. So what this means is that there is a respiratory acidosis with a metabolic alkalosis. Why? Because if the PCO2 increases, the pH should decrease. But there is some other factor that is causing the pH to. So in this case, if the pH is normal and there is an increase in the PCO2, it means that there is a respiratory acidosis with a metabolic alkalosis. It is a mixed disorder, hence there is no primary and secondary. The explanation for this is that, let's say in the PCO2 increases in the body, the pH should decrease, and the compensatory mechanism will be an increase in plasma bicarbonate. But here there is an increase, the bicarbonate has increased to such a large extent that it made the pH normal. So it means is that what it means is that there is a respiratory acidosis with a metabolic alkalosis, a mixed. So what you can say is that the change in the PCO2 identifies the metabolic disorder. That is, if the PCO2 increases, there is a metabolic acidosis, and if the PCO2 decreases, that there is a metabolic alkalosis. So this is the second step. The third step is determining the anemia. So anyway, I'll just give you an example of a mixed acid-base disorder. So let's say you have a pH of 7.39 and a PCO2 of 24. Right? Now here the pH is normal. The PCO2 is decreased. Right? So you have a mixed respiratory alkalosis with metabolic acidosis. because the pH is normal, the PCO2 is decreased. So the decrease in PCO2 indicates a respiratory alkalosis. The compensatory mechanism has overcompensated, if I may say, and there is a metabolic acidosis. There is as such no term such as overcompensated. So you have a mixed disorder because the pH is normal and the PCO2 is decreased. Now let's say the pH is 7.3, the PCO2 is 38. So here the pH is decreased. The PCO2 is normal. So you have a mixed, again in this case you have a mixed metabolic acidosis with a respiratory alkalosis.